Okay, so we're continuing today with that 5-3-5-5 kind of mashup of SSS and SAS congruence postulates. So we still want to be able to identify congruent triangles by SSS and by SAS. And today we're going to look at a few more cases that end up using some stuff that we know from chapter 1, actually. So some vertical angles and things like that. So we're going to take a look at a couple of cases where we can take advantage of those things, even though they might not be directly labeled in the picture. So we're going to be adding on to our notes today with this. Oh, and that's my puppy. He was too tired to come to school this morning. So he's staying home, little buddy. Okay. There's the top of the paper. Okay, so 5.3/5.5 day 2, SSS and SAS continued. Okay, so today is going to be mostly going through examples of types of problems that you, or types of things that you might encounter on the homework, on tests, things like that, that use different properties and things that we've learned before this chapter on this stuff that we've learned. So just a quick refresher. We had our two theorems, we had, or postulates, we had SAS. So if we had triangles like this, if we had this sort of a situation where we had side, angle, side, side, angle, side, where this angle is the angle that's included between the two sides that we know. This is called the included angle. Then we could say that triangle ABC is congruent to triangle DEF by SAS. Just a quick refresher on what SAS is. And then we had SSS, side, side, side. So if I know the measures of all three, or if I know that there are 3 pairs of corresponding sides that are congruent, then I can conclude the triangles are congruent by SSS. So I could say something like triangle STP is congruent to triangle QLM by SSS. Okay, so that's a quick refresher of what those two postulates were from Friday. Now we're going to look at a couple different examples of cases where not everything is labeled on the drawing for us. We might have to go through and label a few things ourselves. So here we go. We might get a picture like this. So here's our picture. And we might be asked a question like, which postulate would you use to show triangle ABC is congruent to triangle ADC? And then we might also be asked, how do you know? Or why? Okay. So just kind of looking at this one at first glance, we see that we have an angle that's labeled as being the same. We have this angle here, DAC, and this angle here, CAB. And then we have the side AD and the side AB labeled as being the same. So that's only two pieces of information, though. We have one pair of sides and we have one pair of angles so far. So there's something else that I need to show in here that I need to label as being the same in order for this to work out at all, because we need at least three things, right? So here's something to watch for. Anytime they share a side, so anytime we've got a shape like this where there's a side that's in the middle that belongs to both triangles, I need to label that as a side that is congruent here, as a side that we share. Because then we have side, angle, side, and side, angle, side. So this one is SAS. And then if it says, how do you know? Well, then we just list off the things that we know that are congruent. So I know from the picture from the labels in the picture that DA is congruent to AB. And we know that angle DAC is congruent to angle BAC from labels in the picture. So things that were already labeled before we even did anything, we know those parts. Here's the part that's different. I know that this side, AC, is congruent to AC. It's congruent to itself. So what we're doing here is we're acknowledging that this side is shared by both of the triangles. So whenever we see a shared side like this, we have this idea that the side is congruent to itself, and we have to acknowledge it to show that we're basically that we're saying that yes, these two share this side, and that's okay. And we know this looks like one of our properties from 2.4. If you remember all the way back to that, we had like the reflexive, symmetric, and transitive properties, right? It's been a while. This one is the reflexive property. So anytime you see a side being shared by two triangles, that's because of the reflexive property that we can say that they are congruent to each other. And then we're done, because we have labeled the three pieces of information that we need in order to conclude that SAS works for this. So anytime we see a shared side like this, we want to label it. Any questions on that first example? Just to kind of recap, we pick SAS because we notice we're dealing with angles here. So that's really all it could be, is SAS. There's no SSS possibility here because we don't have that third side. And then we just talk about how we know. We know that these two sides are the same. We know that these two angles are the same just from stuff that's labeled in the picture. And then we know that this side is congruent to itself because they share it by the reflexive property. Okay, so let's look at another one. All right, so we might see another picture like that. And we will be asked two things again. Which postulate? And how do you know? So the how do you know part is kind of like showing your work for triangle congruence. So which postulate? How do you know? Okay. So looking on here, are there any shared sides we need to label? And if so, which shared side do we need to label? Yes, Owen. PR. We need to label that because they share it. So then when we go to look at which postulate it's going to be, what do we think? Is it going to be SSS or SAS? What do we think out of our two options? All right, so let's see. Owen says SSS, Marissa says SAS. So looking at this, we have, let's see, we found one pair of sides here. We have another pair of sides here, and then we have a shared side. I don't actually know anything about the angles in this picture. We could try to think, okay, maybe this is a right angle or something like that, but it's not labeled, so I can't make that leap. So this one is going to be SSS because we have the three pairs of sides, and I don't have any information necessarily about the angles right now. With 5.4, we could then make the jump to those angles being the same and stuff like that, but we haven't got to 5.4 yet. So we are going to go with SSS for this one. And now we have to talk about how we know. So the first one from labels. We know that QP and SP are congruent. And then we also know that QR and RS are congruent. And then for the second one, we know that PR is congruent to PR by reflexive property. Okay, so now we've seen an SAS and an SSS example. Both of them using the reflexive property with that shared side. Okay. Now we're going to take a look at something that involves vertical angles. All right, if we see a picture like this, we might also be asked the same questions. Which postulate? And how do you know? Which postulate? How do you know? And we might also be told something like it's ACB is congruent to DCE there. Okay, so looking at this one, the first thing that we need to label is the vertical angles in the picture. Remember, vertical angles are any angles that are formed, that are across from one another when formed by crossing lines. So when you see an X in your picture, vertical angles should be going through your mind. Vertical angles. So we're going to work on recognizing those right there. There's our vertical angles, and vertical angles are congruent. So it's going to, kind of bring us all the way back to chapter 1 here with vertical angles, using those again. So vertical angles right there. So now that we see vertical angles, which postulate do we think we're going to use? SAS or SSS? What do we think? SAS or SSS? All right, yes, we are going to use SAS here. Anytime pretty much right now that you see an angle and two sides going on, we should be thinking SAS. You do want to make sure that it's the angle that's between the two sides for both triangles, that the angle is the included angle. But yeah, the postulate we are going to use here is SAS. How do you know? First one from labels. We know that EC and CB are the same. And we know that AC and CD are the same. That's what was already labeled in the picture for us. Then from the one that we labeled, we know that angle ACB, this angle here, is congruent to angle ECD, this angle right here, because they are vertical angles. Okay. So now we've seen one involving vertical angles. Give everyone a chance to catch up writing here just a moment. And then we will do one more example. All right, last one here. looking at this picture, we have A, B, C, and D. And we're trying to show that these two triangles here are congruent with the information that we have. So what's one more piece of information we need to label? Are there vertical angles? Do they share a side? What's going on here? What other thing should I label? Feel free to type in the chat if you see something that you think I should label. Because there is one more thing. So do they share a side, or do we have vertical angles going on here? Yes, we've got this shared side here. BD. Okay, so we have our shared side. The problem with this one, though, when we see which postulate should we use, we're tempted to say SAS, right? Because we do have an angle and we have two sides. But here's where we have a problem. In order to use SAS, it needs to be a picture that has the included angle between two of the sides. But this angle is not between the two sides that I know. This angle is not the included angle. So when you see a question like this, sometimes they will ask you which postulate, if any of them work, would you use? And then one of your options will be that there's not enough information. This is one of those cases where there is not enough info. And we know because the angle A and angle C is not the included angle. Or SAS. It's not between the sides. We know. So the angle that we know is not the included angle. It's not the angle that's in between the two sides that we know. If I was going to use this angle, I would need to know that these two sides have matches over here. But I don't know that. I only know that these two match and that this one matches itself. So there's not enough info, and we know because the angle that we know is not the included angle. Okay, so those are kind of all the new possibilities that we have for different ways to know different pictures that we might see for triangles to be congruent with SAS and with SSS. So today our assignment is going to be in big ideas. So we're going to go through the first couple big ideas problems together to kind of get an idea of what they're looking for here. And then after that, if you would like more examples or anything, feel free to stick around. But I'm going to go ahead and post the assignment, and we will go through a couple of the problems together. Okay, so here's our big ideas assignment today. When you do this, make sure you use the check answer feature and the help features that are offered if you're stuck. Here we go. We'll do the first couple of problems together. And that's fun. Oh, there it goes. Okay, so on this assignment, there are 15 questions today. A lot of them are click and drag. So the first one says, name the included angle between PK and LK. So for this kind of question, really we just want to know if we can identify the angle that's in between these two line segments. So PK is right here, PK. LK is right here. It's that middle shared line. So between these two segments is this angle right here, LKP or PKL, depending on which way you would like to label it. So you can call it PKL, you can call it LKP. Let's look and see if we can find it down here. And it turns out it is the first one, PKL. So yeah, PKL or LKP is what we're looking for. We find it. That's the included angle between these two sides. So that's just a quick breakdown exercise of finding the included angle. Okay. The next one is a question that's likely to, it's a lot like some of the ones that we saw on our assignment today, or on our examples today. Decide whether there's enough information to show that QRV and TSU are congruent using SAS. So there's two options for yes and two options for no. So we have two pairs of sides and the included angle are congruent. That would be the yes option. Two pairs of sides and a pair of angles not included by the sides are congruent. That would be another yes option. No, the congruent angles are not corresponding parts of the named triangles. That's one reason it could be no. Or no, the congruent angles are not the included angles. That's kind of like example 4 that we looked at. So looking at the picture here, I want to know if this triangle and this triangle are congruent. So we see that there's an angle and we see that there's two sides. Are the angles here the included angle? Is this the angle between my two sides? What do we think? Is angle U between the two sides we know? And is angle V between the two sides we know? No, it's not, right? Because angle U is between SU and UT. But we know ST and UT, not SU. So this angle would need to be over here in order for us to use SAS. So I would say no, the congruent angles are not the included angles. So it's the wrong one. Kind of like with example number 4. The angle that we know is not between the two sides that we know. Okay. Here's another one that's kind of like it. Could we use SAS right here? So we've got this shared side that we know that's congruent. So let's look through our examples real quick. Does anything look kind of like that? Actually, no. Our examples don't look, or well, we've got one that kind of looks like it, but with the sides on different ends. Anyway, okay. So we've got this shared side right here that we would need to label kind of in our mind. And so we have a side, and then we have an angle, and then we have a side here. Is the angle the one that's in between the two sides? Yes. Because this angle right here is between the side that we know that's shared and the side that we know that's labeled. Then we want to make sure and double check the congruent statement, make sure it works out. EFH and GHF, those are talking about the same corresponding part, so we're good there. So we would say yes, two pairs of sides and the angle in between them, the included angles, are congruent. All right, this will be the last one that we go through together. This one is interesting because you kind of have to go through and do exactly what we did in the examples. We have to decide if the triangles are congruent based on SSS, since this one's going to use SSS. And then we have to explain how we know. So we have JKL is congruent to LJM. So first off, looking at this statement right here, JKL, it goes from J to K to L. So this one's a little bit tricky just because we do have to take a look at this congruent statement first, because the two triangles are congruent, but the way that they labeled them is wrong. So if I start off at J and then K and then L, and then for this one I want to start off with L, I can't go from L to J because that goes along the long side first. Because when I started off on this triangle on the left and I went JK, from J to K is one of the short sides. From L to J is my long side. So the congruent statement that they wrote is not quite correct. But we are told that JK, KL, LM, and MJ are all the same length. So that's what it's talking about next. You are given that JK is congruent to LM and MJ, and then we have to pick the fourth side that is missing there. So we had JK, KL, LM, MJ. So KL is the one that's missing here. Then it talks about JL. Remember, that's the side that we would label kind of in our head as being the same as itself, because it's a shared side, right? So if it's a shared side, JL is congruent to JL. And if we look back at our notes, that was the reflexive property that told us that JL is congruent to itself. So then we can say that JKL is actually congruent to, you could pick LMJ, because that would go, JKL goes short side, long side. LMJ goes short side, long side. Okay, so that's probably going to be the hardest kind on here. So just using the kind of the how do you know process here. If you're into writing things down on paper, write down the things in your diagram that you know. Write down that we know that these four sides are all the same length. Write down that we know that JL is congruent to JL. And then kind of try and put those things in here. Okay. So for those of you who feel like you're ready to roll for the assignment, you can go ahead and get started. For those of you who would like to stick around and get more help, I will do another one of these with you guys if you would like. So stick around if you want more help. Go ahead and get started, and you're free to leave the Google Meet if you do not want more help.